Hello everybody, this is Meghraj and I welcome you to my YouTube channel. Today we are going to solve the next numerical of chapter Light. A student wants to project the image of a candle flame on the walls of the laboratory by using a lens. First part, what should be the nature of lens and why? Second part, if the magnitude of the focal length of the lens is 10 centimeter, at what distance should he place the flame so as to get a, first case is magnified image, second case is diminished image on the wall. Now the third part, what will happen if he places the flame at a distance of 5 centimeter from the lens? Draw a label diagram to justify your answer. So dear friends, this question is more about the concept rather than the numerical. Now let's see what the first part is. The first part is all about figuring out what kind of lens it is. So if you have to obtain the image on the wall, so it is already given in the question, wants to project the image of a candle flame on the walls. So if you want to obtain an image on a surface that is screen, then the image has to be real. So which is the lens that forms a real image? That is the convex lens. So converging lens or convex lens will be required to get an image on the wall. So, because it forms the real image. The concave lens doesn't form a real image in any of the two cases. So, that was the answer to the first part. Now, let's see what the second part is. If the magnitude of the focal length, so here they have given the focal length. How much it is? 10 centimeter. So, always remember the magnitude, that is the 10 centimeter, that will be in positive sign because the focal length of a convex lens is always in positive. Okay, now what we have to find, if the focal length is 10 centimeter, at what distance should he place the flame to get a magnified image? So we already know that if the object is placed between 2f1 and f1, then we can get an magnified image. If the object is placed exactly on f1, then also we can get highly magnified image. Okay, that will be highly magnified. We just want magnified as per the question. So the object has to be placed between 2f1 and f1. Okay, so then the image that will be forming here will be magnified. So flame must be kept between 10 to 20 centimeter. Why 10 to 20? Because the focal length is 10 centimeter and 2f will be 20. So this point will be 10, this point will be 20. So it should be kept between 2f1 and f1. That is between 10 centimeter to 20 centimeter to get a magnified image. So this question is more about the concept than the numerical. So what is the next part? If he has to get a diminished image on the wall where the object should be or the flame should be kept. Now for that you can see the object or the flame should be kept just before 2f1, that is just before 20 centimeters. So flame must be kept just before 20 centimeter to get diminished image. Okay, so this is object size, this is image size, so image forming will be shorter than the object right here. And the last part, that is, what will happen if he places the flame at a distance of 5 centimeters? So dear friends, the focal length is already given as 10 centimeters. So if he places something at 5 centimeters, that will be exactly between the optical center and the focus. So that will be in this case. So in this case, the image that will be forming will be a virtual and erect image which will be forming before 2f1. Okay, so the real image will not form in the case where we kept the flame exactly at 5 centimeter from the optical center of the lens. So dear friends, that's all for today. Thank you very much for watching this video. I'll see you in the next video. Subscribe to my channel and hit the bell icon to never miss a video. Thank you very much.